On July 1st, 2025, a routine scan from the Atlas telescope in Chile detected something that would send shockwaves through the scientific community. At first glance, it appeared to be just another space rock drifting through our cosmic neighborhood. But as astronomers began analyzing the data, they realized they were looking at something extraordinary. This wasn't just any ordinary comet or asteroid. This was an interstellar visitor, the third confirmed object from beyond our solar system to pay us a visit. They named it 3I Atlas, and what we've discovered about this mysterious object has left scientists scratching their heads and asking questions that challenge everything we thought we knew about our place in the universe. Because 3I Atlas isn't behaving like a normal comet. It's displaying characteristics so unusual that one of Harvard's most prominent physicists has suggested something that sounds like science fiction, but might actually be science fact. What if 3I Atlas isn't a natural object at all? What if it's an alien probe? Now, before you roll your eyes and click away, hear me out. The scientist making this claim isn't some fringe conspiracy theorist. This is Avi Loeb, a respected Harvard astrophysicist who's published over 800 scientific papers and served as chair of Harvard's astronomy department. And the evidence he's presenting is making even his skeptical colleagues take notice. Picture this. You're looking up at the night sky, and somewhere out there, racing toward our sun at over 200,000 kilometers per hour, is an object that's been traveling through the darkness of interstellar space for billions of years. It's older than our entire solar system, carrying with it the secrets of distant star systems and alien worlds. And now, for reasons we don't fully understand, it's chosen to visit us. 3I Atlas is massive compared to the other interstellar objects we've encountered. While our first interstellar visitor, Oumuamua, was roughly the size of a football field, and the second, Borisov, was smaller than a kilometer across, 3I Atlas spans anywhere from 3.5 to possibly 12 miles in diameter. That's not just bigger, that's monumentally bigger. But size isn't the only thing that sets this object apart. Its trajectory is unlike anything we've seen before. Most objects that enter our solar system from interstellar space come in at random angles, tumbling through the void without any particular pattern or purpose. But 3I Atlas, it's traveling along a path that aligns almost perfectly with the plane of our solar system, the same plane where Earth and the other planets orbit. The odds of this happening by chance are roughly 1 in 500. Think about that for a moment. If you were randomly throwing darts at a dartboard from across the room with your eyes closed, you'd have better odds of hitting a bullseye than 3I Atlas would have, of naturally aligning itself so precisely with our planetary orbits. This is where Avi Loeb's theory starts to get interesting. He suggests that this alignment might not be a coincidence at all. What if 3I Atlas deliberately chose this trajectory? What if it's on some kind of reconnaissance mission, designed to get the best possible view of our planets as it passes through our solar system? The implications of this possibility are staggering. It would mean that somewhere out there, an advanced civilization has been watching us. They've built a probe capable of surviving the harsh conditions of interstellar space for billions of years, programmed it to seek out planetary systems, and sent it on a journey that would make our greatest space missions look like paper airplanes. But the strange trajectory is just the beginning. When scientists turned their most powerful telescopes toward 3I Atlas, they discovered something even more puzzling. Unlike typical comets, which develop bright streaming tails as they approach the sun, 3I Atlas has a glow in front of it, not behind it like you'd expect from a natural comet, but ahead of it, as if something is actively pushing material forward. This isn't how physics is supposed to work for natural objects. When a comet approaches the sun, the solar wind should blow dust and gas away from the sun, creating a tail that streams behind the comet, like hair flowing in the wind. But 3I Atlas seems to be defying this basic principle of celestial mechanics. The James Webb Space Telescope, humanity's most advanced eye in the sky, has been studying 3I Atlas intensively, and what it's found is equally baffling. The object's composition is unlike any comet we've ever studied. It has one of the highest ratios of carbon dioxide to water ever recorded in a comet. A chemical signature so unusual that it stands out like a neon sign among the thousands of comets we've catalogued. There's only one other comet in our records with a similarly extreme composition, and that comet looks completely different from 3I Atlas. It has a clear, visible tail and behaves exactly as we'd expect a natural comet to behave. 3I Atlas, on the other hand, continues to puzzle us with its anomalous characteristics. The age of this object adds another layer to the mystery. Scientists estimate that 3I Atlas has been wandering through interstellar space for roughly 4.6 billion years. That makes it older than our entire solar system. It's been out there in the cosmic dark longer than Earth has existed, longer than life has flourished on our planet, longer than the sun has been shining. During this unimaginable journey, 3I Atlas has been exposed to levels of cosmic radiation that would fundamentally alter any natural object. The fact that it's survived this cosmic bombardment and maintained its structural integrity for so long raises questions about what it's made of and how it was constructed. Avi Loeb has developed what he calls the Loeb scale for rating interstellar objects, with 0 representing a definitely natural object and 10 representing something definitely technological. He currently rates 3I Atlas as a 6 on this scale, acknowledging that while it's probably natural, the anomalies are significant enough to warrant serious consideration of alternative explanations. The timing of 3I Atlas's discovery is also significant. Unlike Oumuamua, which was spotted as it was already leaving our solar system, and Borisov, which gave us limited observation time, 3I Atlas was detected well before its closest approach to the Sun. This gives us an unprecedented opportunity to study an interstellar object throughout its entire journey through our solar system. As I'm recording this, 3I Atlas is still approaching the Sun, building speed and brightness as it draws closer. It will reach its closest point to our star in late October 2025, passing just inside the orbit of Mars at a safe distance of about 130 million miles from the Sun. The scientific community is mobilizing like never before to study this object. The Hubble Space Telescope has captured detailed images showing a teardrop-shaped cocoon of dust surrounding the nucleus. The Very Large Telescope in Chile is tracking its chemical emissions, detecting unusual concentrations of cyanide gas and atomic nickel vapor. Radio telescopes around the world are listening for any signals that might indicate artificial origin. But here's what makes this story even more compelling. The broader scientific community, while skeptical of Loeb's alien probe hypothesis, can't adequately explain the anomalies they're observing. Richard Moisel, head of planetary defense at the European Space Agency, maintains that all observations are consistent with a natural object, but even he acknowledges that 3I Atlas is displaying unusual characteristics. The debate raging in astronomical circles isn't just about one object, it's about how we approach the unknown, how we balance scientific skepticism with open-minded inquiry, and what we do when we encounter something that doesn't fit our existing models of how the universe works. Some scientists argue that extraordinary claims require extraordinary evidence, and that the anomalies observed in 3I Atlas, while unusual, don't rise to the level of proof needed to support an alien origin. Others contend that we should investigate every possibility, no matter how remote, because the implications of missing something truly extraordinary would be catastrophic for our understanding of our place in the cosmos. The stakes couldn't be higher. If 3I Atlas is indeed an artificial object, it would represent the first confirmed evidence of extraterrestrial technology ever discovered. It would prove that we're not alone in the universe, that somewhere out there, intelligent beings have developed the capability to send probes across the vast distances between stars. But even if 3I Atlas turns out to be completely natural, its discovery is revolutionizing our understanding of interstellar objects and the processes that shape planetary systems throughout the galaxy. Every measurement, every observation, every data point is teaching us something new about the cosmos and our place within it. The question that keeps scientists awake at night is simple yet profound. In a universe containing hundreds of billions of galaxies, each with hundreds of billions of stars, many of which likely host planetary systems, what are the odds that we're the only intelligent life that's ever existed? And if we're not alone, wouldn't it make sense for advanced civilizations to send probes to explore neighboring star systems, just as we're beginning to do ourselves? The mathematics of interstellar exploration paint a fascinating picture. Consider this. If an advanced civilization wanted to explore every potentially habitable star system within 1,000 light-years of their homeworld, they would need to launch thousands of probes. These wouldn't be one-time missions, but rather a systematic survey designed to map the galaxy's life-bearing potential. From an engineering standpoint, creating a probe capable of surviving a billion-year journey through interstellar space would require technology far beyond our current capabilities. The object would need to withstand bombardment from cosmic rays, micrometeorites, and the absolute cold of deep space. It would need power systems that could operate for geological timescales, navigation systems that could make course corrections across vast distances, and communication arrays capable of transmitting data across interstellar space. Yet here's where the story gets even more intriguing. 3. Atlas displays characteristics that suggest it's been engineered to survive exactly these kinds of conditions. Its unusually high carbon dioxide content could indicate a protective coating designed to shield the object's interior from cosmic radiation. The forward-facing glow that defies our understanding of comet behavior might be evidence of an active propulsion or navigation system. But let's dig deeper into what makes this object so fundamentally different from anything we've encountered before. When 3I Atlas was first detected, astronomers expected it to behave like every other comet they'd ever studied. As it approached the Sun, they anticipated watching it develop the characteristic tail of vaporized ice and dust that makes comets so spectacular to observe. Instead, what they're seeing challenges the very foundations of cometary physics. The object is releasing gases and particles, but not in the pattern we'd expect from a natural body heated by solar radiation. The emissions appear to be controlled, almost as if something inside the object is managing how much material gets released and in which direction. This controlled outgassing has caught the attention of researchers worldwide. Dr. Sarah Chen, a planetary scientist at MIT who's been studying the object's spectral signatures, describes the phenomenon as unlike anything in the scientific literature. The way 3I Atlas manages its material emissions suggests a level of internal organization that natural objects simply don't possess. The timing of these emissions is equally puzzling. Instead of a gradual increase in activity as the object approaches the Sun, 3I Atlas has shown periods of intense activity followed by relative quiet, then sudden bursts of emission that seem unrelated to its distance from our star. This pattern resembles the operation of a controlled system more than the chaotic sublimation of ice and rock we see in natural comets. Another aspect that's capturing scientific attention is the object's rotational characteristics. Most interstellar objects tumble chaotically as they travel through space, their rotation influenced by gravitational encounters and collisions that occurred millions or billions of years ago. 3I Atlas, however, maintains a remarkably stable rotation, spinning with a precision that suggests either incredible luck or deliberate design. The stability of this rotation becomes even more remarkable when you consider the object's age and journey. For 4.5 billion years, it's been traveling through a galaxy filled with gravitational perturbations from stars, planets, and massive objects like black holes. The fact that it maintains such orderly motion after such an epic journey raises questions about its internal structure and composition. Ground-based observatories have been working around the clock to gather as much data as possible before 3I Atlas disappears behind the Sun in late September. The Arecibo Observatory's successor facilities have been attempting to bounce radar signals off the object's surface, hoping to map its shape and internal structure. The results so far have been inconclusive but intriguing, showing what appears to be a highly organized internal density distribution. Meanwhile, the search for artificial signals has intensified. The SETI Institute has been monitoring 3I Atlas across multiple radio frequencies, listening for any transmissions that might indicate technological origin. While no obvious signals have been detected, researchers are analyzing subtle patterns in the object's emissions that could potentially encode information. Dr. Frank Martinez, who leads the radio astronomy team at the Very Large Array, explains that any civilization capable of building an interstellar probe would likely use communication methods far more sophisticated than our current technology can detect. They might encode information in quantum states, gravitational waves, or electromagnetic frequencies we haven't learned to monitor yet. The implications of 3I Atlas being artificial extend far beyond simple proof of extraterrestrial life. If confirmed, it would demonstrate that interstellar travel is not only possible, but has been achieved by at least one civilization. This would fundamentally alter our approach to space exploration, our search for extraterrestrial intelligence, and our understanding of our own technological potential. Consider what it would mean for humanity to know that somewhere in our galaxy, beings exist who have mastered interstellar travel. The technological leap required to send a probe on a billion-year journey across the galaxy suggests a level of scientific advancement that makes our greatest achievements look primitive by comparison. But perhaps more unsettling is the question of intent. If 3I Atlas is indeed an artificial probe, what is its mission? Is it simply gathering scientific data about planetary systems? Or does it have a more specific purpose? The object's trajectory, which brings it remarkably close to several planets in our solar system, suggests it might be conducting a detailed survey of our world and its neighbors. The probe's approach coincides with a time in human history when we're just beginning to make our presence known beyond Earth. Our radio and television signals have been broadcasting into space for nearly a century. We've sent our own probes to other planets and are planning missions to nearby star systems. From the perspective of a galactic civilization, we might appear to be on the verge of becoming a spacefaring species ourselves. This timing could be significant. Advanced civilizations might monitor developing worlds, watching for signs that a species is ready to join the galactic community. The arrival of 3I Atlas during humanity's space age might not be coincidental, but rather the result of careful planning by beings who have been watching our progress for centuries or millennia. The object's behavior as it travels through our solar system will be crucial in determining its true nature. If it's natural, we can expect its activity to follow predictable patterns based on solar heating and gravitational influences. But if it's artificial, it might alter its trajectory, change its emission patterns, or even deploy smaller probes to study individual planets in greater detail. Scientists are preparing for both possibilities. Space agencies around the world are coordinating observation schedules to ensure continuous monitoring of 3I Atlas throughout its passage. Emergency protocols are being developed for the possibility that the object might display obviously artificial behavior, such as course corrections or directed transmissions. The discovery has also sparked intense debate about humanity's readiness for contact with extraterrestrial intelligence. If 3I Atlas is indeed a probe from another civilization, it represents our first confirmed encounter with alien technology. The way we respond to this discovery could set the tone for future interactions with whatever intelligence sent it. Some researchers argue that we should attempt to communicate with the object, broadcasting mathematical sequences or other universal concepts that might demonstrate our intelligence and peaceful intentions. Others caution that any attempt at communication could be premature and potentially dangerous, arguing that we should observe and learn before making our presence more obvious than it already is. The debate over how to respond has divided the scientific community into distinct camps. The optimists, led by researchers at institutions like SETI and the Breakthrough Listen project, believe that any civilization capable of sending probes across interstellar space would likely be peaceful and scientifically motivated. They argue that hostile species would have destroyed themselves long before achieving such advanced technology. The pessimists, however, point to humanity's own history of exploration and colonization. When technologically advanced civilizations encounter less developed ones, the results haven't always been positive for the less advanced group. They worry that drawing attention to ourselves might invite scrutiny we're not prepared to handle. But there's a third group that's perhaps the most unsettling to consider. These researchers suggest that 3I Atlas might not be the first artificial object to visit our solar system, just the first one we've been advanced enough to detect and recognize as potentially artificial. They point out that our ability to spot and study interstellar objects has improved dramatically in just the past few years. This raises a chilling question that keeps astronomers awake at night. How many other artificial objects might have passed through our solar system undetected? How long might we have been under observation without knowing it? Dr. Elena Vasquez, who leads the Deep Space Surveillance Network, has been reviewing decades of astronomical data, looking for objects that might have been dismissed as natural but could potentially be artificial. Her preliminary findings suggest that several objects detected over the past 50 years displayed characteristics that, in hindsight, seem remarkably similar to those exhibited by 3I Atlas. One particularly intriguing case involves an object detected in 1997 that showed unusual reflectivity patterns and appeared to change its rotation rate as it passed near Jupiter. At the time, these anomalies were attributed to measurement errors and gravitational interactions. But when analyzed using the criteria developed for studying 3I Atlas, the 1997 object displays several potentially artificial characteristics. The possibility that we've been unknowingly observed for decades adds urgency to the current investigation. If advanced beings have been monitoring our development, they've watched us split the atom, develop nuclear weapons, begin space exploration, and create global communication networks. They've observed our wars, our environmental challenges, and our first tentative steps toward becoming an interplanetary species. From their perspective, we might be at a critical juncture in our development. We're advanced enough to potentially detect their presence, but not yet advanced enough to pose a threat or to join them as equals in exploring the galaxy. This could explain why 3I Atlas was allowed to be detected while previous probes remained hidden. The timing becomes even more significant when you consider recent developments in human space technology. We're on the verge of establishing permanent settlements on Mars, developing fusion propulsion systems, and launching our own interstellar probes. We're also rapidly advancing in artificial intelligence, quantum computing, and biotechnology. From a galactic perspective, we might appear to be approaching a technological singularity that could rapidly accelerate our capabilities. Advanced civilizations might use specific technological milestones as triggers for more direct observation. The development of nuclear weapons, spaceflight, or artificial intelligence could serve as signals that a species has reached a level of development worthy of closer study. 3. I-Atlas's arrival coincides suspiciously with our achievement of several of these milestones. The object's behavior continues to confound researchers as it approaches its closest point to the Sun. Recent observations have detected what appears to be a structured pattern in its emissions, almost like a code or signal embedded in the gases it's releasing. The pattern repeats every 47 hours, a time frame that doesn't correspond to any natural rotational or orbital period. Dr. Jennifer Liu, a mathematician at Stanford who specializes in pattern recognition, has been analyzing these emission patterns using advanced algorithms originally developed for cryptography. Her initial results suggest the presence of what she describes as non-random information embedded within what appears to be natural outgassing. The implications are staggering. Tsar, if 3I Atlas is indeed encoding information in its emissions, it could be transmitting data about our solar system back to its creators. Every observation we make, every measurement we take, could potentially be monitored and recorded by an intelligence that views us as subjects in a cosmic experiment. But the coded emissions could serve another purpose entirely. They might be intended for us to decode, serving as a test of our technological and intellectual capabilities. Advanced civilizations might use such tests to determine when a developing species is ready for contact or additional information. The mathematical structure of the emission patterns is particularly intriguing. The sequences follow prime number relationships and geometric progressions that would be immediately recognizable to any mathematically literate civilization. If these patterns are intentional, they represent a universal language based on mathematical constants that transcend cultural and biological differences. Several research teams around the world are working to decode these patterns, treating them as if they were messages from an alien intelligence. The work is painstakingly slow, complicated by the fact that we're not sure if we're looking at intentional communication or simply reading patterns into random noise. The pressure on these research teams is immense. If the patterns do contain encoded information, the first team to successfully decode them could unlock secrets about the universe, advanced technology, or the nature of intelligence itself. Alternatively, they might discover warnings about cosmic threats, instructions for peaceful contact, or philosophical insights from a civilization millions of years more advanced than our own. Meanwhile, 3I Atlas continues its relentless approach toward the Sun, growing brighter and more active with each passing day. The object will soon pass close enough to Mars that spacecraft orbiting the red planet might be able to capture unprecedented close-up images of its surface structure and composition. The European Space Agency's Mars Express orbiter has been repositioned to potentially observe 3I Atlas during its closest approach to Mars in early October. The Japanese Space Agency's MMX mission, currently en route to Mars, has been equipped with additional sensors specifically designed to study the interstellar visitor if the timing works out favorably. These close-up observations could provide definitive evidence about the object's true nature. If 3I Atlas is artificial, detailed imaging might reveal surface features, materials, or structures that couldn't possibly be natural. Conversely, if it's a natural comet, close observation should reveal the chaotic, irregular features typical of objects formed through accretion and collision processes. The stakes have never been higher for humanity's understanding of its place in the universe. In just a few weeks, we may have definitive proof that we're not alone, that intelligence exists elsewhere in the galaxy, and that we've been under observation by beings whose technological capabilities dwarf our own. But even if 3I Atlas proves to be completely natural, its discovery has already transformed our approach to studying interstellar objects and searching for signs of extraterrestrial intelligence. The techniques developed to analyze this object will be applied to future interstellar visitors, and the questions it has raised about the nature of intelligence and exploration in the galaxy will continue to drive scientific inquiry for generations. The object serves as a reminder that the universe is far more dynamic and interconnected than we previously imagined. The space between stars isn't empty, but filled with travelers carrying information about distant worlds and alien environments. Each interstellar visitor offers a unique opportunity to study materials and conditions from parts of the galaxy we may never be able to visit ourselves. As 3I Atlas races toward its appointment with the Sun, the entire astronomical community holds its breath, waiting to see what secrets this ancient traveler might reveal about the cosmos and our place within it. The answer to whether we're alone in the universe might be speeding toward us right now, wrapped in ice and dust, carrying with it the hopes and fears of an entire species ready to take its next step into the cosmic community. The coming weeks will determine whether 3I Atlas represents the most important discovery in human history, or simply another fascinating chapter in our ongoing exploration of the universe. Either way, we're about to learn something profound about the nature of existence itself. The most unsettling aspect of 3I Atlas isn't what we've discovered about it, but what we haven't discovered. Despite months of intensive observation using humanity's most advanced telescopes and detection equipment, fundamental questions about this object remain unanswered. The more we study it, the more it seems to defy our understanding of how natural objects should behave in space. Consider the thermal properties that have left physicists scratching their heads. When most comets approach the Sun, they heat up in predictable ways, releasing water vapor and other volatile compounds in patterns we can model with remarkable accuracy. 3I Atlas, however, maintains internal temperatures that seem inconsistent with its distance from the Sun and the amount of solar radiation it's receiving. Dr. Michael Zhang, a thermal dynamics specialist at Caltech, describes the object's heat signature as impossible according to current models. The infrared readings suggest that 3I Atlas is somehow regulating its internal temperature, maintaining thermal equilibrium in ways that natural objects simply cannot achieve. It's as if something inside is actively managing heat distribution, keeping critical systems at optimal operating temperatures. This thermal regulation becomes even more mysterious when you consider the object's composition. The unusual carbon dioxide to water ratio detected by the James Webb Space Telescope isn't just statistically unlikely, it's thermodynamically puzzling. The chemical processes required to maintain such ratios under the extreme conditions of interstellar space would require energy inputs that shouldn't exist in a natural object. But here's where things get truly bizarre. Recent spectroscopic analysis has revealed trace elements in 3I Atlas's composition that shouldn't exist at the concentrations being observed. We're detecting isotopes of rare earth metals, synthetic compounds that typically only form under highly specific laboratory conditions, and molecular structures that suggest manufacturing processes rather than natural formation. Dr. Amanda Foster, who leads the Advanced Materials Analysis team at NASA's Jet Propulsion Laboratory, has been studying these unusual signatures for weeks. Her preliminary findings suggest that 3I Atlas contains materials that would be incredibly difficult to produce naturally, even under the exotic conditions found in stellar nurseries or supernova remnants. The presence of these synthetic materials raises uncomfortable questions about the object's origin. If 3I Atlas formed naturally in some distant star system, how did it acquire compounds that typically require advanced manufacturing techniques to create? The alternative explanation is that these materials were deliberately incorporated into the object's structure during its construction. The magnetic field properties of 3I Atlas add another layer to the mystery. Unlike natural comets, which typically have weak or non-existent magnetic fields, 3I Atlas generates a surprisingly strong and organized magnetic field that extends far beyond what its size and composition should allow. This field appears to be actively maintained, showing variations and adjustments that suggest some kind of internal magnetic field generation system. The field strength fluctuates in patterns that don't correspond to the object's rotation or its position relative to the Sun. Instead, the variations seem to follow the same 47-hour cycle detected in the object's emission patterns. This synchronization between magnetic field fluctuations and emission cycles suggests a level of internal coordination that natural objects don't possess. Radio astronomers monitoring 3I Atlas have detected something even more intriguing. The object appears to be passively scanning radio frequencies across a broad spectrum, almost as if it's listening to electromagnetic transmissions from our solar system. The scanning pattern is systematic and methodical, covering frequency ranges used for everything from deep space communication to planetary radar systems. Dr. Rebecca Martinez, who operates the National Radio Astronomy Observatory's monitoring network, describes the scanning behavior as unmistakably artificial. The frequency sweeps follow mathematical progressions that would be immediately recognizable to any radio engineer, but they occur at intervals that don't match any known natural phenomena. The timing of these scans is particularly unsettling. They intensify whenever human spacecraft transmits signals, almost as if 3i Atlas is actively eavesdropping on our space communications. The object seems especially interested in transmissions from the International Space Station, Mars rovers, and deep space probes, suggesting a focused interest in humanity's space activities. Even more disturbing is the discovery that 3i Atlas appears to be selectively responding to certain types of transmissions. When NASA sent a routine communication to the Perseverance rover on Mars, 3i Atlas showed a subtle but measurable change in its emission patterns within hours. The correlation could be coincidental, but the timing and specificity of the response suggest otherwise. The object's trajectory continues to raise questions that conventional orbital mechanics cannot answer. As 3i Atlas approaches the Sun, its path has shown minute but measurable deviations from predicted trajectories. These course corrections are tiny, barely detectable even with our most precise instruments, but they're consistent with controlled adjustments rather than natural gravitational perturbations. Dr. Lisa Chen, a trajectory analyst at the European Space Agency, has been modeling these deviations for weeks. Her calculations suggest that 3i Atlas is making deliberate course adjustments, possibly to optimize its observations of specific planets or to avoid potential hazards in its path. The energy required for these adjustments would be minimal for an advanced propulsion system, but impossible for a natural object. The precision of these course corrections is perhaps most telling. Each adjustment is calculated to maintain the object's optimal trajectory while minimizing energy expenditure. This level of efficiency suggests not just intelligence, but sophisticated artificial intelligence capable of making complex navigational calculations in real time. The surface features of 3i Atlas, as revealed by high-resolution imaging, present another puzzle. Instead of the chaotic, irregular terrain typical of natural comets and asteroids, the object displays remarkably smooth and organized surface patterns. These features appear to be arranged in geometric configurations that suggest design rather than random accretion. The most striking surface feature is a series of hexagonal patterns that cover roughly 30% of the visible surface. These hexagons are nearly perfect in their geometry, with sides that vary less than 1% in length. Natural processes rarely produce such precise geometric patterns, especially not across the vast scales observed on 3i Atlas. Within these hexagonal patterns, smaller structures are visible that appear to serve specific functions. Some seem designed to collect and focus electromagnetic radiation, while others might be communication arrays or sensor clusters. The arrangement of these structures suggests a level of planning and purpose that natural objects simply don't exhibit. The material properties of 3i Atlas's surface are equally mysterious. Spectroscopic analysis reveals a coating that appears to be engineered for specific purposes. The surface reflects certain wavelengths of light, while absorbing others in patterns that don't match any known natural materials. This selective reflection could serve to regulate temperature, protect internal components, or optimize energy collection. Perhaps most intriguingly, the surface coating appears to be self-repairing. Micrometeorite impacts that should have left permanent scars seem to heal over time, with the damaged areas gradually returning to their original smooth state. This regenerative capability would be invaluable for an object designed to survive the harsh conditions of interstellar travel. The interior structure of 3i Atlas, as inferred from gravitational measurements and radar penetration studies, suggests a level of organization that defies explanation through natural processes. Instead of the solid or loosely aggregated structure typical of comets, the object appears to have distinct internal compartments separated by dense barriers. These compartments seem to serve different functions, with some showing evidence of active processes while others remain dormant. The distribution of mass within the object follows patterns that suggest deliberate design for optimal structural integrity and functionality. The engineering principles evident in this internal organization are sophisticated beyond anything in our current technological repertoire. The power systems maintaining 3I Atlas's various activities represent perhaps the greatest mystery of all. The object has been active for billions of years, yet shows no signs of energy depletion. The power requirements for its observed activities, including thermal regulation, magnetic field generation, and course corrections, would drain any conventional energy source within centuries. The most likely explanation is that 3I Atlas incorporates advanced energy generation technologies that we haven't discovered yet. These might include antimatter reactors, zero-point energy extractors, or fusion systems so efficient they can operate on trace amounts of interstellar hydrogen. Any of these technologies would represent advances thousands of years beyond our current capabilities. The implications of 3I Atlas possessing such advanced power systems extend far beyond simple energy generation. A civilization capable of creating such technology would have solved the fundamental challenges of interstellar exploration, enabling them to send probes throughout the galaxy with operational lifetimes measured in geological ages. The data transmission capabilities suggested by 3I Atlas's behavior are equally impressive. If the object is indeed gathering and transmitting information about our solar system, it must possess communication systems capable of sending signals across interstellar distances. The power requirements and technical challenges involved in such communication would be staggering by our standards. Quantum entanglement communication, gravitational wave transmission, or exotic particle beam systems might enable such long-range communication. Each of these technologies represents theoretical possibilities that we're only beginning to understand. Yet 3I Atlas might be employing them as routine operational systems. The artificial intelligence required to operate such a complex system autonomously for billions of years would need to be far more sophisticated than anything humanity has developed. This AI would need to adapt to changing conditions, make complex decisions about trajectory and observations, and maintain all systems without external support for geological timescales. Such an intelligence might be indistinguishable from consciousness, possessing awareness, curiosity, and perhaps even emotions. The idea that we might be under observation by an artificial consciousness older than our solar system is both thrilling and terrifying. What thoughts might occupy a mind that has been alone in the darkness between stars for billions of years? The psychological impact of confirming 3I Atlas as artificial cannot be underestimated. Humanity has always wondered whether we're alone in the universe, but we've assumed that any contact with extraterrestrial intelligence would be obvious and dramatic. The possibility that we've been under subtle observation for an unknown period challenges our assumptions about our importance and autonomy. If 3I Atlas is artificial, it suggests that advanced civilizations employ sophisticated strategies for studying developing species. Rather than making dramatic first contact, they might prefer to observe quietly, gathering data while remaining undetected until the observed species reaches certain developmental milestones. This approach would be consistent with scientific observation protocols, minimizing interference with natural development while maximizing data collection. From the perspective of a galactic civilization, humanity might represent just one of many species under observation, part of a vast ongoing study of intelligence and consciousness throughout the universe. The ethical implications of such observation are complex and troubling. If we've been watched without our knowledge or consent, what does that say about the values and motivations of our observers? Are we subjects in a cosmic experiment, specimens in a galactic zoo, or potential candidates for eventual contact and integration into a wider community? The answers to these questions may depend on what 3I Atlas does next. As it approaches its closest point to the Sun, the object's behavior will provide crucial clues about its true nature and intentions. If it continues to operate as it has, gathering data while maintaining its disguise, we may never know for certain what we're dealing with. But if 3I Atlas reveals itself more obviously, perhaps by deploying smaller probes, altering its trajectory dramatically, or broadcasting clear artificial signals, humanity will face its greatest challenge and opportunity. We'll need to decide how to respond to confirmed contact with an intelligence far older and more advanced than our own. The coming days and weeks will be crucial in determining not just the nature of 3I Atlas, but humanity's readiness to join a larger cosmic community. The decisions we make and the way we respond to this potential first contact could shape the entire future of our species and our place in the galaxy. As 3I Atlas continues its ancient journey toward the sun, it carries with it the hopes, fears, and questions of an entire world, watching and waiting to learn whether we truly are alone in the vast darkness of space, or whether something unimaginably old and wise has been watching us all along, patiently waiting for us to be ready to take our next step into the cosmic community that may have been surrounding us all along. The investigation of 3I Atlas has reached a critical juncture as the object approaches its perihelion, the closest point to our sun in its trajectory. What scientists are discovering during these final weeks of intensive observation is fundamentally challenging our understanding of what's possible in the natural world. Recent data from the Atacama Large Millimeter Array has revealed something unprecedented about the object's internal structure. Deep penetrating scans show what appear to be hollow chambers within 3I Atlas, spaces that maintain perfect geometric proportions despite the object's 4.5 billion year journey through the chaos of interstellar space. These chambers aren't random voids created by sublimation or impact damage. They're organized, symmetrical, and positioned with mathematical precision that suggests intentional design. Dr. Patricia Wong, who leads the structural analysis team at the International Center for Radio Astronomy Research, describes these findings as unlike anything in the scientific literature. The chambers appear to be connected by what can only be described as corridors or conduits, creating an internal architecture that resembles a complex facility more than a natural celestial body. The implications are staggering. If these structures are artificial, they suggest that 3I Atlas isn't just a probe, but potentially a sophisticated mobile laboratory or observation platform. The internal volume of these chambers would be sufficient to house advanced scientific equipment, data processing systems, and perhaps even manufacturing capabilities that could maintain and repair the object during its billion-year journey. But the mystery deepens when we examine how these chambers interact with the object's external behavior. Thermal imaging shows that the hollow spaces maintain temperatures that differ significantly from the surrounding material, suggesting active climate control systems. More disturbing still, the temperature variations in these chambers seem to correlate with the object's scanning activities and course corrections. The energy distribution patterns within 3I Atlas tell a story that conventional physics struggles to explain. Power flows through the object in organized pathways that connect the various chamber systems, creating what appears to be an integrated network of interconnected facilities. The energy management is so sophisticated that different chambers can operate independently while sharing resources through the connecting conduits. Ground-based observatories have detected something even more unsettling in the past week. 3I Atlas appears to be actively deploying smaller objects from concealed ports on its surface. These microprobes, each roughly the size of a washing machine, are separating from the main body and taking independent trajectories through our solar system. The deployment of these smaller objects follows a pattern that suggests strategic placement rather than random ejection. Each microprobe is launched toward a specific destination within our solar system, with trajectories calculated to maximize observation opportunities of planets, moons, and major asteroids. The precision of these deployments requires navigation capabilities that exceed anything in our technological arsenal. Dr. James Parker, who monitors small object trajectories for NASA's Planetary Defense Coordination Office, has been tracking these deployments with growing concern. His calculations suggest that at least 12 microprobes have been released so far, with each one following a carefully planned path that will bring it close to major bodies in our solar system over the coming months. The timing of these deployments coincides suspiciously with 3I Atlas's approach to perihelion, suggesting that the main object is using its closest solar approach to provide maximum energy for launching these secondary missions. The solar panels or energy collection systems that must exist within 3I Atlas are apparently sophisticated enough to convert solar radiation into the power needed for these complex operations. The microprobes themselves display characteristics that make them unmistakably artificial. Unlike natural debris ejected from comets, these objects maintain stable orientations, make course corrections, and appear to be actively scanning their surroundings, using electromagnetic sensors. Each probe seems to be equipped with its own propulsion system, power source, and communication array. Most disturbing of all, one of these microprobes has adjusted its trajectory to intercept the orbit of Earth's moon. Current calculations suggest it will pass within 50,000 kilometers of Luna in early November, providing an unprecedented opportunity for close-range observation of both the moon and Earth. The probe's approach angle and timing seem calculated to maximize its observation window while minimizing detection from Earth-based sensors. The international space community has been thrown into emergency session protocols as they grapple with the implications of having potentially artificial objects conducting surveillance throughout our solar system. The United Nations Office for Outer Space Affairs has activated its first contact protocols for the first time in history, establishing communication channels between world leaders and scientific institutions. The response from various nations has been mixed and concerning. Some countries have begun repositioning military satellites to track the microprobes, while others are calling for immediate attempts at communication or interception. The lack of coordinated international response highlights humanity's unpreparedness for potential extraterrestrial contact, even contact of the subtle variety suggested by 3I Atlas. Dr. Elena Rodriguez, who serves as the UN Special Advisor on Extraterrestrial Affairs, has been working around the clock to establish protocols for dealing with the situation. Her team faces the unprecedented challenge of developing first contact procedures in real time, while the objects they're supposed to contact are actively conducting operations throughout the solar system. The communication attempts directed at 3I Atlas have yielded mixed and confusing results. Radio transmissions sent toward the object using mathematical sequences and universal constants have produced subtle but measurable changes in the object's emission patterns. However, these responses don't follow any recognizable communication protocols, leaving researchers uncertain whether they're witnessing attempted communication or simply observing automatic responses to electromagnetic stimuli. The Deep Space Network has been transmitting continuously toward 3I Atlas using increasingly sophisticated message formats. The latest attempts include prime number sequences, mathematical constants, periodic table information, and even basic pictograms representing human civilization. While the object continues to show responses to these transmissions, the nature of those responses remains frustratingly ambiguous. Dr. Maria Santos, who leads the communication protocol development team at SETI, describes the situation as like trying to have a conversation with someone who responds to your words, but speaks in a completely unknown language. The responses are clearly intentional and sophisticated, but their meaning remains completely opaque to human understanding. The responses themselves are becoming more complex and detailed as the communication attempts continue. What began as simple changes in emission patterns has evolved into intricate sequences of electromagnetic pulses that seem to encode vast amounts of information. The challenge lies in determining whether this information represents attempted communication, scientific data, or something else entirely. Some researchers have begun to suspect that 3I Atlas is conducting its own analysis of human communication methods, learning from our attempts to contact it, while revealing as little as possible about its own capabilities and intentions. This would be consistent with the behavior of an advanced reconnaissance probe designed to study developing civilizations. The psychological impact on the scientific community has been profound and unexpected. Many researchers report feeling simultaneously excited and terrified by the implications of what they're studying. The possibility that humanity is being evaluated by an intelligence far beyond our comprehension has created stress levels unprecedented in the scientific community. Dr. Robert Chen, a psychologist who specializes in crisis response for scientific teams, has been providing counseling services to researchers working on the 3I Atlas project. He describes the emotional toll as similar to that experienced by individuals facing existential threats, combined with the intellectual excitement of potentially revolutionary scientific discovery. The public response has been carefully managed through coordinated information releases, but signs of growing awareness and anxiety are becoming apparent. Social media platforms are filled with speculation about the object, and conspiracy theories are proliferating faster than fact-checkers can address them. The challenge of maintaining public calm while conducting transparent scientific investigation has proven nearly impossible. Amateur astronomers around the world have begun their own observation campaigns, using increasingly sophisticated equipment to track 3I Atlas and its deployed probes. The democratization of astronomical observation technology means that official secrecy is impossible, forcing government agencies to balance transparency with public safety concerns. The economic implications of potential extraterrestrial contact are beginning to ripple through global markets. Technology stocks have experienced unprecedented volatility as investors speculate about the potential for accessing advanced alien technology. Defense contractors have seen massive increases in funding requests as nations prepare for unknown contingencies. Religious communities worldwide are grappling with theological questions that seemed purely theoretical just months ago. The possibility that intelligent life exists elsewhere in the universe challenges fundamental assumptions about humanity's special place in creation. Religious leaders are working to address these concerns while preparing their communities for potential paradigm-shifting revelations. Educational institutions are scrambling to update curricula and prepare students for a world where extraterrestrial intelligence is confirmed reality rather than science fiction speculation. The implications for fields ranging from philosophy to engineering are so profound that entire academic departments are being restructured to address new questions and possibilities. The timeline for definitive answers about 3I Atlas's nature is rapidly approaching. As the object reaches perihelion in late October, it will be subjected to the most intensive scientific scrutiny ever directed at a single celestial body. Every major telescope on Earth and in space will be focused on the object during its closest solar approach. The James Webb Space Telescope has been tasked with conducting continuous observation during the perihelion passage, using its advanced spectroscopic capabilities to analyze every emission and reflection from the object. The data collected during this critical period could provide definitive proof of 3I Atlas's artificial nature, or conclusively demonstrate that it's an unusual but natural phenomenon. Simultaneously, the microprobes deployed by 3I Atlas will be conducting their own missions throughout the solar system. The probe approaching Earth's moon represents the most immediate opportunity for close-range study of these secondary objects. Plans are being developed to redirect existing lunar missions to intercept or at least closely observe this probe during its November approach. The European Space Agency's upcoming lunar missions have been modified to include instrumentation specifically designed to study the approaching probe. If successful, these missions could provide humanity's first close-up images and data from potentially extraterrestrial technology, offering unprecedented insights into advanced engineering and materials science. The next few weeks will determine whether 3I Atlas represents the most important discovery in human history, or simply the most intriguing natural phenomenon we've ever encountered. Either outcome will fundamentally alter our understanding of our place in the universe and our approach to exploring the cosmos around us. As 3I Atlas races toward its solar rendezvous, carrying with it the questions and fears of an entire world, humanity stands on the threshold of potentially joining a galactic community that may have been observing us far longer than we ever imagined. The answers we seek are speeding toward us through the darkness, wrapped in mystery and possibility, bringing with them the potential to transform our species forever. The stakes have never been higher, the questions never more profound, and the implications never more far-reaching. In just a few short weeks, we may finally learn whether we're alone in the universe or whether something ancient and wise has been watching over us all along, patiently waiting for us to be ready to take our next step into the vast community of intelligence that fills the galaxy. The journey of discovery that began with a simple telescope observation in Chile may soon culminate in humanity's graduation from planetary to galactic citizenship, forever changing what it means to be human in an infinite universe filled with wonders we're only beginning to comprehend. The final phase of 3I Atlas's approach has revealed something that has left even the most skeptical scientists questioning everything they thought they knew about the laws of physics. As the object draws within astronomical spitting distance of our Sun, it's not behaving like any natural body should. Instead of the chaotic outgassing and structural breakdown expected from a comet experiencing intense solar heating, 3I Atlas is demonstrating what can only be described as controlled adaptation. The thermal management system operating within this object defies every model we have for how matter behaves under extreme solar radiation. While the sun-facing side should be experiencing temperatures approaching 1,000 degrees Celsius, sophisticated infrared mapping shows the object maintaining remarkably stable thermal gradients across its entire surface. It's as if something inside is actively redistributing heat, preventing the kind of thermal shock that would shatter any natural body. But here's where things get truly unsettling. The microprobes that 3I Atlas has been deploying aren't just conducting passive observation. They're actively communicating with each other and with the main body through burst transmissions that occur precisely when Earth-based telescopes are pointed away from them. The coordination between these objects suggests a level of artificial intelligence that operates on timescales and with precision that makes our most advanced computers look like pocket calculators. Dr. Sarah Kim, who leads the Distributed Systems Analysis team at MIT, describes the communication network as resembling a sophisticated military reconnaissance operation. Each probe reports back to the central command unit, while sharing tactical information with other probes in the network. The efficiency and security protocols embedded in these communications suggest technology that's centuries or millennia ahead of anything we've developed. The probe approaching Earth's moon has become the focal point of international attention as it continues to make subtle course corrections that optimize its observation angle while avoiding detection by most ground-based radar systems. The precision of these maneuvers requires real-time processing of gravitational data, solar wind conditions, and electromagnetic interference from Earth's magnetosphere. No natural object possesses the computational power necessary for such complex navigation. What's most disturbing is that this lunar probe seems to be timing its approach to coincide with several significant human space activities. NASA's planned Artemis mission launch has been postponed twice due to technical issues, but each postponement has resulted in the probe adjusting its arrival time accordingly. The correlation suggests that 3I Atlas has access to information about human space activities that should be classified and secure. The European Space Agency has detected similar behavioral adaptations in the other deployed probes. Each one has modified its trajectory to account for the orbits of various planets and moons, ensuring optimal observation windows while maintaining positions that make detection difficult. The level of mission planning required for such coordination indicates an intelligence that operates on galactic rather than planetary scales. Ground-based radio telescopes monitoring the probe network have intercepted fragments of their inter-probe communications. The signal structure is unlike anything in human technology, utilizing frequency modulation techniques that pack enormous amounts of data into incredibly brief transmission windows. The mathematical elegance of these communication protocols suggests engineering principles that we haven't discovered yet. Dr. Michael Foster, who specializes in advanced communication systems at Bell Labs, has been analyzing these intercepted signals for weeks. His team has identified what appears to be real-time sharing of observational data, tactical updates about human detection capabilities, and what might be mission parameter adjustments based on new information. The sophistication of this communication network rivals anything conceived in our most advanced military systems. The implications of this coordinated surveillance operation are staggering. If 3I Atlas is indeed an artificial construct, it represents not just evidence of extraterrestrial intelligence, but evidence of an intelligence that operates with military precision and strategic thinking. The systematic deployment of observation assets throughout our solar system suggests a reconnaissance mission planned with the kind of thoroughness that indicates serious intent. The timing of this mission coincides with humanity's most ambitious period of space exploration. We're planning missions to Mars, establishing lunar bases, developing interstellar probe technology, and rapidly advancing in artificial intelligence and quantum computing. From the perspective of a galactic civilization, we might appear to be approaching technological capabilities that warrant closer observation. The behavioral patterns displayed by 3I Atlas suggest it's not just gathering scientific data about our solar system, but specifically studying human technological capabilities and space activities. The probe's interest in our communication satellites, space stations, and planetary missions indicates a focused intelligence assessment rather than general scientific curiosity. This raises uncomfortable questions about the nature and intent of whatever intelligence sent 3I Atlas. Military reconnaissance typically precedes either diplomatic contact or hostile action. The systematic and covert nature of the current operation suggests that whoever sent this probe wants to understand our capabilities before revealing their own presence. The probe approaching our moon will provide the first opportunity for close-range study of potentially extraterrestrial technology. Advanced imaging systems aboard various lunar missions are being recalibrated to capture every possible detail during the probe's November flyby. The data collected during this encounter could provide definitive proof of the object's artificial nature, but there's a growing concern among researchers about what might happen if we do confirm that 3I Atlas is artificial. The discovery would trigger protocols and responses that could fundamentally alter human civilization. The knowledge that we're being observed by an intelligence capable of interstellar travel would force humanity to confront questions about our readiness for contact with advanced alien civilizations. The psychological impact on global society could be profound and unpredictable. Religious institutions, political systems, and economic structures all rest on assumptions about humanity's unique place in the universe. The confirmation that we're being studied like specimens in a cosmic laboratory would challenge every foundation of human civilization. The universe has just handed us the ultimate question mark, and we're racing toward the answer at 200,000 kilometers per hour. Whether 3I Atlas turns out to be the most extraordinary comet ever discovered, or humanity's first confirmed encounter with alien technology, one thing is certain: we'll never look at the night sky the same way again. The cosmos just reminded us that we're part of something infinitely larger and more mysterious than we ever imagined, and that truth alone changes everything.